Exercise 7.9 NCERT textbook. Question number 1. Integration -1 to 1 x plus 1 dx. It will become x squared by 2 plus x, limits -1 to +1, which can be written as x squared 1 by 2 outside, limits -1 to 1, plus x, limits -1 to 1. It will become 1 squared minus -1 squared plus 1 minus -1. 1 by 2 into 0 plus 2. That is 2. Let's go to next question. Question number 2. Integration 2 to 3 dx upon x will become log x, limits 2 to 3, which is equal to log 3 minus log 2, which will be equal to log 3 by 2, because log m minus log n is equal to log m upon n. Let's go to next question. Question number 3. Question 3 says 1 to 2 integration 4x cube minus 5x square plus 6x plus 9 dx. It will become 4x power 4 by 4. So 4 will cancel out. Minus 5x cube by 3 plus 6x squared by 2 plus 9x, limits 1 to 2. We can write separate limit 1 to 2 minus 5 by 3 x cube 1 to 2 plus 3 times x squared, limits 1 to 2, plus 9 times x, limits 1 to 2. We put the values, so it will become 2 power 4 minus 1 power 4, that's 1, minus 5 by 3, 2 power 3 minus 1 power 3, plus 3 times 2 power 2 minus 1 power 2, plus 9 times 2 minus 1. If we evaluate it, we will get 64 by 9. Now, let's go to question number 4. Question number 4 says integration 0 to pi by 4 sine 2x dx. This question can be solved by substitution also, but here I'm solving it by direct method. So formula sine ax dx integration gives minus cos ax divided by a. So it will become minus cos 2x divided by 2, limits 0 to pi by 4. So minus 1 by 2 outside, cos 2x, limits 0 to pi by 4. 1 by 2 cos 2 times pi by 4 minus cos 2 into 0, that is 0. Minus 1 by 2, this will be cos pi by 2, which is 0, and cos 0 is 1. So from here, we will get 1 by 2. Let's go to question number 5. Question number 5. It says integration 0 to pi by 2 cos 2x dx. Again, I'm going to apply direct formula. Cos ax dx gives sine ax divided by a. So this will become sine 2x divided by 2 limits 0 to pi by 2, which can be written as 1 by 2 sine 2x limits 0 to pi by 2, which will be equal to 1 by 2 sine 2 times pi by 2 minus sine 0. So it will become 1 by 2 sine pi minus sine 0. If you remember, both values are 0 because graph of sine x is like this. This value is pi, which is 0, and this is 0. So this is 0, this is 0. So both will be 0. So we will get 0. Let's go to question number 6. Question number 6 is integration from 4 to 5 e power x dx. It will become e power x 4 to 5, that is e power 5 minus e power 4. We can take out e power 4, then e minus 1 will be left, which is our answer. Let's go to question number 7. Question number 7 says integration 0 to pi by 4 tan x dx. This can be written as integration 0 to pi by 4 sine x dx divided by cos x. We put cos x equal to t minus sine x dx equal to dt. Here I'm not going to change the limit. There is another method where we can change the limit, but I'm keeping it simple. So we write it 0 to pi by 4, and this will become minus dt upon t, which will become minus log t limits 0 to pi by 4. We put the value of t as cos x minus log cos x limits 0 to pi by 4. We can write minus sign outside and then we put the limits. So it will become minus log cos pi by 4 minus cos 0 minus cos pi by 4 is 1 upon root 2 minus cos 0 is 1. But sorry, here I have put wrong limit. So it will become log cos pi by 4 minus log cos 0. So it will become minus log, this will become 1 upon root 2 minus, this is log 1, and log 1 is 0. So here we write it log 1 minus log root 2 minus log 1. So log 1 will cancel out, and this minus will make this minus plus. So log root 2, we can further write it as log 2 power half. Then by applying log n power n, we can write it 1 by 2 log 2, which is our answer. Now let's go to question number 4. Sorry, question number 8. Question number 8 says pi by 6 to pi by 4 cosec x dx. So if you remember the formula, integration cosec x dx gives log cosec x minus cot x. So we can write it log modulus cosec x minus cot x limits pi by 6 to pi by 4. So we first put pi by 4. So log cosec pi by 4 minus cot pi by 4 minus log cosec pi by 6 minus cot pi by 6. So log, this will become root 2 minus 1 minus log, this will become cosec pi by 6. So it will give 2 minus cot pi by 6. This will give root 3. We apply log m minus log n formula. So it will become log of root 2 minus 1 upon 2 minus root 3. This is our answer. Now let's go to question number 9. Integration 0 to 1 dx upon root of 1 minus x square. We know that integration of dx upon root 1 minus x square is sine inverse x. So it will become sine inverse x 0 to 1, which can be written as sine inverse 1 minus sine inverse 0. Sine inverse 1 means pi by 2 and sine inverse 0 means 0. So answer is pi by 2. Let's go to question number 10. Question number 10. Integration 0 to 1 dx upon 1 plus x square. We know that integration dx upon 1 plus x square gives tan inverse x. Tan inverse x limits 0 to 1, which will be tan inverse 1 minus tan inverse 0. Tan inverse 1 means pi by 4 and tan inverse 0 means 0. So answer is pi by 4. Thank you for watching.